In this video, let's try some logical simplification exercises. So simplify the following. First move, let's try De Morgan's. So we have to apply De Morgan's twice. So this will be the negation of P and not of R quantity, or so this is not of P and not of Q or Q or R and R or P. One thing to note or to be careful around this problem is the precedence of and or. So conjunction here has a higher precedence. So basically we have three main terms here. So after that we could simplify this one by double negation. So double negation. After double neg, we'll have P and not of R. Simply copy the other terms. So around here we could apply distributive, but first let's apply commutative. So commutative and distribute. So this would be R or Q and P. So now we have four terms. One is R, and we could associate R with the first term, and distribute. So associate and distribute. So giving us R or P and R or R. Or negation of R. So this one we could simplify this by negation property. So this will amount to truth, and with this proposition it will simplify as identity. So negation and identity. Negation and identity will give us R or P. After that, we could try association of P and the second term and the third term. So this will become P, so associate and distributive again. So association so this will be R or P or not of P and P or not of Q. So this term will simplify by negation and identity again. So commutative identity. So let's just use negation, commutative, and identity. Will give us, so this is true, and will give us this term only, so P or not Q. Therefore, what will be left will be R or P or not of Q or Q and P. So down to our last stretch, we will try again associative, so association and distributive. So it's just a series of associative, distributive. So we will have R or P, or in this case we are distributing the not of Q to this term. So this will be not of Q or Q and the not of Q or P. So after this, we will have another negation. So this will be true and commutative and another identity. So negation, commutative, and identity. So we will have, what's left now will be R or P, or so this will be true. By identity, what will be left now will be not of Q or P. But we have two P variables here. So by finally by idempotent or associative with idempotent and associative, or associative and idempotent. So the final answer of the simplification will be R or not of Q or P. And that's it, the final answer. So for the second exercise, we'll have a similar problem, but notice that their operators, logical operators, are now this one is the and then or. So instead of the or and. So this is a bit simpler. Similar step. We'll start with De Morgan's, and we will have the not of P and not of R, and not of P, and not of Q, and Q or R, or R or P. So we have basically we have two terms, this one term here and this one. Again, AND has a different, or has a higher precedence than OR, so that means we cannot simplify, we cannot associate these two in the last part. So one thing that is noticeable here is, let's try double negation first, so that we could simplify this about a bit farther. So P, the neg of P will become P, and not of R, and not of P, and not of Q. So this is noticeable here that the operator is all ANDs. So therefore associative can be executed in these statements. So let's copy this further. Okay. So by association, we could have associate P and not P. So by associative property, we have now P and not of P, and let's just have R and Q and not of Q. So, and Q or R or P. So in this case we have negation. So by negation property, this will be true, and negation with identity. So negation, commutative, and identity. Negation, commutative, just to reverse the order, and identity. So this will simplify to not R and not of Q, and this term Q or R or R or P. So in this case we could simplify this term. I have how many terms now? So this is all ANDs, or so you have two terms basically. So I could associate this one by associative property, associate this term and distribute. So let's associate and distribute. We could associate this R to this one as well. Anyway, so associative and distribute. I forgot. This one should be false, because this is an AND statement. So this will be a bit simpler, because this will no longer be an identity. This will be a domination. So domination. So this false statement will dominate the R, will dominate the Q, and will also dominate the Q or R. So this will be a bit simpler now. So by domination, how many domination do we have? So domination 1, so this will be false, and then after that domination 2, and then 3. So domination will be applied 3 times. So applying domination 3 times, this will become false. So this will cut off the solution now. So after this, by commutative, and after commutative identity, you will have the result to be R or P. That's it.